All right, welcome to the first video. We're going to start today talking about the Cartesian Coordinate System. I can start by drawing a couple perpendicular lines here. Okay, and it's the Cartesian Coordinate System. Sort of like a map, okay? It's a map for describing points in the plane. Okay, you have XY, where X denotes the horizontal position, and Y denotes the vertical position. Okay, so if we look here, for example, if I wanted to plot the points 2, 3, I would go 2 to the right, 3 up, and I would say that's 2, 3. Okay. Another point I might want to give, let's say -2, 3. So that's 2 to the left, 3 up, and this point here is -2, 3. Okay. Another point I might want to give, let me erase that here because it doesn't really do anything over there since it's over here already. Another point I might want to give is -2, -3. Okay. 2 to the left and 3 down. And then finally, 2, -3. Okay, 2 to the right and 3 down. Now, I don't need this here either. Okay, now we split this up. These have quadrants, we call them, 4 quadrants. First quadrant has both coordinates being positive. Second quadrant has the x-coordinate being negative and the y-coordinate positive. Third quadrant is marked by both coordinates being negative. Fourth quadrant is marked by a positive x-coordinate and a negative y-coordinate. Okay, so let's both positive here, negative positive here, both negative here, positive negative here. Okay. All right. Next thing we're going to talk about is we're going to talk about the distance formula. Okay, but before we do that, we're going to talk about the Pythagorean theorem because that's all the distance formula is. Or, really, the Pythagorean theorem in the Cartesian plane. Okay, so let's talk about the Pythagorean theorem real quick. All right, given a right triangle Okay, Pythagorean theorem requires that you're using a right triangle with sides A, B, C, C being the hypotenuse, then A squared plus B squared equals C squared. Okay, so there's our triangle with a right angle there. I don't like that right angle yet, so let me, a little better. ABC. Okay, so let's just do a really quick, just a little proof of this. So we're going to do a little proof, draw a couple of squares here. Okay, so we're going to imagine that this square has sides A plus B. Okay, but we're going to split it up in two different ways. So first, let me see, I think I might be able to copy this. I don't think so. Never mind, we'll just do another one. Bad square, but oh well. Also going to have sides A plus B. Okay, we're going to split this up two ways. Okay, so over here on this left side, we're going to say we have A here, B here, and we have A here, B here. All right, so we have A squared being the area of this square here, B squared being the area of this square here, and then these rectangles on the sides are going to have area AB each. Okay, now we're going to go over here, we're going to do this again, but we're going to split it up differently now. We're going to start out the same way here with A, here with B. But now here, we're going to make this side A and this side B. Still haven't done anything different. But what we're going to do is we're going to connect these with the line here. Okay. Now on this side, we're going to make A being here. And so we're going to connect this with a line like so. Here's B. And now A we're going to have up here. Okay. So now, if this triangle up here has sides A, B, C, and these are supposed to represent the same, then this badly won, but still it's a right triangle. This inner square has sides C. So this inner square has area C squared. Okay. All these triangles, I have 4 of them. Well, we know the area of a triangle is 1/2 AB. Okay, so since we know that these two squares are the same, then we must have a squared plus b squared plus 2ab has to equal on this side c squared plus, there's 4 of these little triangles with 1/2 AB being their area. Well, these cancel, so we get a squared plus b squared equals c squared. Okay, so that's not really super necessary for you guys to know how to do, but it's just kind of fun. Let's see, how does the distance formula become, or how does the Pythagorean theorem become the distance formula? So let's take ourselves draw a coordinate plane. Okay, and let's start with, say, the points 4, -5, -4, -5. And the points 2, 3. Okay, so our problem is to find the distance between these 2 points. Okay, now later on we'll get a formula, but right now we don't have to think about it so much as a formula. What I'd like us to think about is, let's imagine that we had another point down here. Okay, so this point down here, if I make a right triangle out of here, this is going to have the x-coordinate being 2 and the y-coordinate being -5. So the Pythagorean theorem is going to be, well, we have to ask ourselves, what's the distance between -4 and 2? Okay, so the key point is to realize the distance between -4 and 2, how far away those are, is simply 6. Okay, what's the distance between -5 and 3? Well, -5 and 3 are 8 away from each other. So that's an ugly 8. So our distance, let's say our distance squared, is going to be 6 squared plus 8 squared. Okay, so our distance is going to be the square root of 36 plus 64. Oh, square root of 100, and that's just 10. Okay? More generally, given 2 points, x1, x1, y1, and x2, y2, the distance between them is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. Now, that's the formula, okay, but I'm going to actually, oftentimes, I'm going to treat it as just the Pythagorean theorem as I did up here. Okay? All right, let's do a couple of examples. Okay, let P be the point M comma B, and Q be the point B comma M. So we don't know what M and B are, but they're just arbitrary numbers. And we're going to find the distance PQ between the points. Okay, now, well, D is going to be the square root. Now, how far are M and B apart from each other? Well, any 2 points, or any 2 points on a line, M and B, are just you take the difference of them to find how far apart they are. M minus B squared plus, over here, we're going to let's take B minus M. Now, when you square these come and give you the same thing, right? When you square M minus B, you get the same thing as when you square B minus M. So, you're going to get, under the square root, 2 M minus B squared, or, if you like, 2 B minus M squared. They're going to be the same thing. Okay, now, let's get rid of that square root. Well, you're still going to have the square root of 2, but now, instead of M minus B, you're actually going to have the absolute value of M minus B, or the absolute value of B minus M. Okay, so first thing I want you guys to sort of realize, sort of a little rule, the square root of x squared is actually the absolute value of x. Okay, so just keep that in mind. It's very easy to say that it's x, but it's not always x, because if x is negative, then you'll have the negative of x. Okay, I know it's confusing. All right, we're gonna go to, I'm gonna go stop this video here, and we'll have another example on the next page.